Hello. Let me go over the remaining uh, question for test. So the question here is asking, we have the measuring heart rate for heart rate for patient among patient. And we have four groups. We are trying to see if there is any difference among those groups. So this is the ANOVA table. You have 7.47, and so and the question is at least your knowledge all these four groups are equal. At least one of the mean is different. You can have several comparison like group control versus drug one, control versus drug two, and so forth. So we're saying at least one of those comparison could be different. So one thing, you have your test statistics 7.47. You would go and look at the F table. F table, you have your numerator with your model here 3, and then denominator is 56 is your error. So 3 and 56 is 2.769. That's the critical value. So if your test statistics is greater than the table value you reject, you would say at least one of these heart rate are different in terms of conclusion. So the second part, I asked you, look at the 2T output and tell me what is the difference. Here we said control is different from A, B, C. Drug A is different from B. Drug A is different from C. The way you find it is based on if you see any connection. Here we see A is definitely different from B and C because there is no connection between control and these three drugs. And also, drug A is not connected to drug B and C. B and C is connected to each other. So basically, all of these statement is correct. A is different from B and C. A is different from B, and A is different from C. So all of the above question is correct. So the question 2 here, we have 58 patients in one clinic, and we want to examine social support by race, group, and sex. So here again, overall model is significant. That is your regression, multiple regression. And here race is the only variable. And so you have type 1 and type sort of type 2, type 3. So you wanted to look at what is, I asked you, what is overall F? It's here 3.04. What effects are significant in terms of main? So you wanted to look at type 3 here. So group is significant point at alpha 0.05, and also race is significant. So these are two variables. Both factor, group, and race are significant because the p-value is less than 0.05. So that's the answer for this question. Now, it says we have these output, and I ask you to calculate the Pearson correlation for age and triglyceride. So again, age and Y is your 0.85. Experiment correlation for again, that was Pearson. That is experiment for weight, and triglyceride is 0.70. And then it's testing if age and weight is related. All of these p-values, these are your p-values, it tells you is less than 0.05, so therefore they are significant. So here we have multiple regression model. Again, your triglyceride is your outcome, age. This is simple regression. So I ask you, write the prediction equation. Again, you have intercept for the intercept is negative 0.06 plus 1.76, your age. That is the correct answer. And then for second model, you have two of these, negative 64 plus 1.37 age plus 0.44 weight. So that would be for your multiple regression. And I model two, this is the model two, if the slope is significant, sort of weight, it is because the p-value is less than alpha 0.05. So you sort of, again, looking at the p-value 0.001, so the weight is less than alpha and is significant, so it tells you that. So the weight as, again, we use weight as independent. So here, again, 0.0001 for simple, the model 2 I was looking. So either in the full model or in the basically in simple regression model, weight is significant. Now, R square, adjusted R square for model 3 is 0.78. And then, and I ask you to predict, you put it in the model, 42 years old and 132, and you come up with 51.43. So this is another question we have for heart attack and for group. So you have cases controlled versus they take aspirin or not. So it's chi-square. So I ask you expected value for cell 2 and 3. So the first value is your observed, the second value the expected. So the second cell is 45, the third one is 55. And this is your cell percentage, that means 30 divided by 200. This is your row percent, that means 30 divided by 90. And that is column percentage, that means 30 divided by 100. So those are the percentage, the information, the chi-square. What is the chi-square value? Is 18.8. And if it's significant, yes, because the p-value is less than 0.001, so it becomes significant. Here is the, some of the questions related to rate. What is the crude birth rate per 1,000? Here you're looking at total live birth during the year, total population. So you have 500,000 divided by 38 million times 10,000, you get 131.58. And general fertility rate, you're using total number of live births during a year divided by total number of women childbirth aging, which is 500,000 divided by 10 million times, you get 500. So that's basically using a correct formula and replacing the value you have it. And here I ask you to calculate relative risk and what it means, and odds ratio. Basically, the relative risk is 50 divided by 350. Over 10 divided by 650, you get 9.29, and that means those who are exposed to secondhand smoking are 9.29 times more likely to develop heart condition, excuse me, as compared to those who do not expose to second. And the odds ratio, again, you can use the formula AD over BC. This is your A, B, C, D, 50 over times 64. 640 divided by 300 over 10 give you 10.67. That means the odds of developing disease is 10.67 times higher for those exposed to secondhand smoking compared to not exposed. Again, for relative risk, you go from exposed to condition. Odds ratio, you go from the condition to exposure. Here we had a few questions I asked you. We have a random sample of 12 patients in clinic and given quality of life instrument A researcher does not know the distribution of quality of life. She wanted to test if the average of quality of life different from a standard score. What test you would use? Do you use non-parametric? Yes, because the sample size is small. Probably you wanted to use that. What statistical test you would use? Probably because it's one sample, you use sign rank test. Now, if you have two groups, we're adding another group, so you use Wilcoxon sign rank test, which is similar to the t-test. Now, if you have more than two groups, it's like a parametric version would be ANOVA. Here you're using Kruskal-Wallis test, which is similar to ANOVA in parametric test. So I hope this help you to understand what you missed in the problem. If you have any question, you can contact me.